Welcome everyone to today's CSIA webinar series. My name is Colin Hammond and I will be your host today. For those of you who are unfamiliar with CSIA, we are a global nonprofit professional association with over 500 member companies in 40 countries. Our mission is to advance the practice of control system integration to benefit our members and their clients. Our vision is to ensure that manufacturing and process industries everywhere have access to low risk, safe, and successful application of automation technology. CSIA membership offers members access to resources needed to attain and exceed business goals. To highlight just a few of our many member benefits, the CSIA Best Practices Manual guides control system integration companies and the setup and the running of solid company. CSIA's business insurance program offers members an excellent insurance program and includes members from all over the world enjoying the peace of mind that comes with CSIA insurance. Clients in all industries are now seeking integrators with a CSIA certification alongside ISO. They recognize CSIA certified integrators' commitment to industry standards and business acumen, and as a result, being certified can shorten the sales cycle. CSIA Industrial Automation Exchange is the premier automation guide featuring system integrators and suppliers who provide industrial, manufacturing, and process automation solutions. For integrators and suppliers, it's a place to market their expertise. Clients will find white papers, case studies, capabilities, contact information, and engage in conversation directly with CSIA members. And please follow CSIA's online event calendar for all upcoming webinars, including partner webinars and business webinars. You won't want to miss these opportunities to learn from the comfort of your own office or home. And for more information about CSIA, please visit our website or contact us at info@staff.controlsys.org or 847-686-2245. And at this time, I would like to introduce our speakers.
All right.
Colin Geis, Director of Product Management, Data Acquisition. Colin is currently the Director of Product Management at Redline Controls, a global industrial communications company with 15 years of professional experience in local and global business. He brings an insightful perspective on IoT trends, and Rufus Brown, Applications Engineer. Rufus is currently an applications sales engineer for Redline Controls, covering the southeastern United States. With over 22 years of experience in industrial automation, he brings an expertise in control systems, protocols, data collection, and electromechanical solutions. And with that, I would like to pass it over to Colin and Rufus. Welcome, gentlemen.
Hey, thank you. All right, so let's jump in. So today I'm here to talk about the OT-IT convergence in industrial automation. So quick review of the agenda. We're going to talk about kind of what is the OT-IT convergence, what are some of the driving forces behind it right now, both on the southbound, as in the asset or product side of it, as well as the northbound, the infrastructure, wherever the data is going. We'll talk about how Redline is addressing the OT-IT convergence, as well as we'll wrap up with some real-world applications from my colleague Rufus Brown. And at the end, we'll have some time for some Q&A. So you can submit those questions in the chat window or the Q&A window, and we'll address those at the end. So I just wanted to take a brief moment to walk through Redline's history. Which started in 1972 with encoders. A few short years later, in 1976, we're leading the market with panel meters. By 93, we were offering HMIs with multi-protocol capabilities, doing M2M communication. It wasn't, in fact, until 1999 that the term IoT was introduced, which is curious because we were producing products that were doing that a half decade earlier. In 2004, we released industrial cellular communications. And then it wasn't until about 3 or 4 years later that the first consumer-based iPhone was released. In 2011, Industry 4.0 was announced. And then the very following year, we launched this product, the Productivity Station, which was a plant floor display, which was able to take operational data or production data and visualize it real time for operators or technicians to see how the process, how the plant was performing right there. Since 2013, Red Lion's had a really strong track record of launching very innovative and market-leading products. In 2013, we launched the Graphite platform, which was a hardened modular HMI. In 2016, we were one of the first companies to embed MQTT or pre-built, pre-configured MQTT connectors into cellular routers, making it very easy for users, operators to connect operational data out in the field to cloud brokers, for example. In 2018, we leveraged that same cloud connectivity with the pre-configured clients and embedded it into our protocol converters. So now operators could take any one of our 300 industrial protocols and seamlessly push it to the cloud in just a couple clicks of a button. Just earlier this year, we launched this product called FlexEdge. And the vision for this product is anything in, anything out, anywhere. And the reason I bring this up is Red Lion's history has changed from encoders to very digitized, networking heavy products. And we're seeing the exact same transition in the industrial automation market today. And that's what we're going to be talking about. So let's talk about what is the OT-IT divide. So the OT-IT divide is the challenge of managing industrial assets and their operational uptime with the infrastructure and teams required to keep the systems operating securely. The divide comes from a wide variety of different areas, but ultimately it's rooted in asset ownership. So for example, hopefully we can recognize that our OT or automation engineers have owned, deployed, operated, and maintained PLCs on the factory floor. However, as these devices are now connected to industrial Ethernet networks, the struggle for who owns the PLC, either the hardware or the software configuration, is becoming unclear. This concept of connecting more assets and moving more data is what's causing the blur between the line of OT and IT. So if we look at the OT-IT divide another way, we can break down the responsibilities of each department. While the overall goal of both departments may be to keep the company producing goods, for example, each team has a very different approach on how to achieve that goal. IT, as you may know, is typically responsible for things like security, accessibility, reliability, data scalability, things like that. Whereas OT is in charge of production uptime, throughput, efficiency, employee or worker safety. As we continue to connect more of this automation equipment, the line of who's responsible and will continue to be a moving line. Is one team responsible for the hardware and another responsible for how it's configured? And how is accountability established between those teams? So it's difficult to read anything today relating to the industrial market without coming across IoT or the OT-IT divide. But the question is, why now? If IoT has been around for 10 years, what's changed in recent years? My interpretation of what I'm seeing over the last decade is that it's a convergence of several trends, not necessarily one. The key drivers from a product perspective is the merging of capabilities into deployed assets. So for example, gateways featuring both control capabilities as well as routing capabilities. Assets are now more powerful than they ever have been previously. Processing power is cheap, storage is cheap, memory is cheap. So enabling one device to handle a variety of these functions is now within the realm of possibility. Again, think gateways or PLCs with advanced networking capabilities. migrating all these capabilities into a single device enables for easier deployment because you're managing fewer devices in that control cabinet or out in the field. So another trend that we're seeing is this idea of internet connectivity is now extremely accessible to everybody. It's also ubiquitous. So be it a physical, Ethernet cable on a plant floor, or Wi-Fi, or cellular, or this next gen 5G, which is coming out. This idea that you can connect anything is really moving to connect everything. And there is a pretty key difference between those two terms. So now that everything is connected and accessible, it means that there's a whole lot of data to move, a whole lot of data to store, and a whole lot of data to protect. This means new tools for finding that golden nugget in that operational data. However, it also means that you need to keep a keen eye on security for everything from the gateway up to the storage of that data. So I want to take a minute and talk about the edge of network. This is another really common phrase in industrial circles. The challenge is identifying where does the edge start or end. So if we look at the top row of blue boxes that I've got here, representing perhaps asset types, we may be able to draw a line for the edge of the network where the devices are specifically used for process control and not just transmitting data. So in this case, perhaps the PLC would be OT or automation, the gateway, and northbound to the right would be IT, which is fine. But if you talk to other customers, sometimes they consider the edge of the network anything outside of IP connectivity. So anything that speaks serial or an industrial protocol or I/O. In this case, does it matter if we use an unmanaged switch versus a managed switch? Who owns which? Finally, a different way to look at the edge of the network is physical location. So where is it physically located? Is everything in a control cabinet the edge, or everything out in the field the edge? So the point of this slide is to demonstrate that within an organization or when communicating with end users, grounding yourself and them with common vocabulary is critical. Simply saying the edge may mean that it's an OT function, and you just need to be aware of the ramifications of that decision or using that sort of language. So if we start at the edge with a gateway, just for example, something as straightforward as deploying a gateway is now a multi-team coordination effort, or at least I argue it should be. Consider that gateways typically aggregated data from local assets and transmitted that data someplace northbound. These data aggregation gateways typically have been seen as OT assets, as they natively spoke industrial protocols and they communicated with other industrial assets. But with the ever-connected infrastructure, who's responsible now for configuring the VPN credentials to connect that gateway to a cloud or to a network operations center? Who's responsible for IPsec routes or enabling radius or inputting certificates for the IoT cloud? So we were recently working with an automation engineer responsible for deploying IoT gateways. The challenge was that IT wouldn't share the credentials with the automation engineer because IoT was an IT function. Clearly, this is something that needs to be worked through. So the question remains, it isn't who is responsible, but which teams are required for successful deployment, and what's the plan for commissioning those assets? So building on the deployment of a gateway, how about planning for the unexpected? Creating a plan for the known is easy. You identify an action, you identify an owner, and you move on. Things like security patches, commonly IT, firmware updates, perhaps OT, or updating databases. These are all easy things to create plans for. But more importantly is, what's the plan for how to troubleshoot problems when a system is down and production is stopped? Is this an IT task to confirm that the network is functioning or not? Is it a firewall issue? Or is it the OT's job to ensure that the configuration on the control device is correct? Also, don't forget about how to plan for things like a burned out power supply. Who owns that? The critical piece here is creating a plan, and you're going to hear this theme a couple more times through this presentation. So again, creating a plan for routine activities is easy, and it's easy to iterate on as you go through security patches. They're very routine. However, creating a plan for the unknown or unexpected, that's the challenging piece here. Do you start with automation or do you start with networking? I can't tell you which is the right path, but what I can tell you is it all starts with communication between teams. How often should those team members be talking when a system or process is down? What's the medium of communication? How do they report out once the problem's been resolved so that you don't have the problem again? Did you learn anything? So meetings like this, it could be post-mortem meetings, for example. Again, it's just setting up a plan for how to approach these. So if we move from the edge of the network into northbound, or if we follow the data, if you will, there's a variety of topics to consider here, but let's for a moment just focus on the data. As you know, data is generated by the sensors, PLCs, drives, or other automation equipment at the edge of the network, but it needs to be transferred someplace for viewing, to be analyzed, simply stored, something like that. As a system integrator, if you stand up or start your own IoT platform or data service, consider who owns the data. Whose equipment is the data moving across? Where does it come to rest? And as a worst case scenario, what happens if data is lost or tampered with? Who's responsible? Who owns it? What's the plan? If your customers are international or take place in the European Union, consider the implications of GDPR laws. We recently had an end user in Germany who had to pick and choose their cloud-based server platform to ensure the data was only stored and accessible from Germany. This critical decision factor was introduced late in the cycle, and it added a lot of delay to the project. But ultimately, we were able to work through that. So now we've talked about the assets, we've talked about the data. So now let's talk about the northbound infrastructure. And so what I'm showing here, the graphic on the left is what a traditional data model looks like. And this is commonly referred to as a Purdue model, for example. The model on the right is what at least Accenture is representing as a data model for the future, or an architecture for the future. The model on the left, the Purdue model, it's very traditional, and it's commonly found in factories where data is very siloed, and it's constructed in a way that it's really limited to just the operational assets or production assets. The model on the right is, as soon as data can be extracted and moved into data pools or hybrid architectures or cloud environments, it is. And the model on the right is where the market is going. There are, however, implications of moving to this route. If I can share another example that we recently encountered, an end user was connecting a remote pump station or multiple remote pump stations that were set up identically. So the same IP address scheme, the same subnets. These sites for the last 10 years simply push data to an in-house SCADA using Modbus, I believe. The customer, however, was migrating to a cloud-based architecture and wanted to connect each one of the pump sites to each other for communication. The challenge was that they didn't want to change any of the IP addresses or subnets of the remote pump stations. So what happens when you connect two sites with identical IP addressing and subnets? It creates network failures. So it wasn't until after the fact that the customer was experiencing these failures that we were brought in to help resolve the issue. In fact, it wasn't really our hardware, it was the architecture that the customer migrated to. So the point of this is that in 30 seconds, if this technician had talked to IT, they could have pointed out the issues with that architecture and come up with a better solution. So when you create a plan, you know, I get asked, what's a good place to start? And you can start with a product life cycle of the PLC, for example, or consider, a customer journey, how they deploy it, how they manage it, how they own it. But the point is, create a plan to address everything from procurement to replacement of the asset. Your plan needs to include which teams are responsible, along with buy-in from those teams. You can't just arbitrarily, set people up. You need to identify and get buy-in on primary and secondary members who are familiar and accountable for the quick resolution of those tasks. Pick a PLC or gateway manufacturer. Picking a PLC or gateway manufacturer should be a multi-team approach. Consider that both OT and IT now are responsible for the success of that asset being deployed. So does IT have say in the security that's being implemented? Does that asset support that, for example? And then finally, what are the tasks or priorities and sign-offs required for each one of those activities? Is your plan flexible enough to account for changes in traditional automation equipment, features, or for example, automation equipment now having advanced networking capabilities? How do you address that? So I'll take just a quick moment and talk about Red Lion's approach to the OT-IT divide and how we're moving forward. So first and foremost, we're attempting to make our products as absolutely easy and intuitive to use. So our recently launched FlexEdge product has a large green LED ring right on the front of the product. And then each one of the communication sleds or IO modules have LED statuses as well. So from 20 feet away, you can see that this product is working well or not. If there's an issue as you get closer, it'll actually show you exactly where the fault is, for example. So making products intuitive and quickly diagnosable. We are approaching the automation market by building in networking into these devices. So FlexEdge, for example, does combine advanced automation capabilities along with powerful networking capabilities. We took a serious look at how IT and OT want to access these industrial assets. So IT traditionally doesn't want to load an application on their computer, open a database, create a database, and push the database to an asset. They want to log into the device via a web GUI, for example, make their networking changes, commit them, and then walk away from the device. Whereas OT wants that desktop. They want that database on their computer to work offline. These products, FlexEdge specifically right now, supports both of those mediums. So we have an online web GUI for IT, and then we also support databases for the OT. Role-based security and also logging or reporting of that. So does your device support role-based security? Can IT or OT make changes to different parts of the database, or can it be locked down? Easily integrate these assets into enterprise authentication servers, for example, Radius servers, so for user authentication. And then finally, security is absolutely a growing concern in the market. How are products addressing security? Via new protocols and actually removing old protocols like TLS, for example, or TLS 1.1. And then finally, certificates. Certificates are being used from everything from advanced routing or networking technologies like VPN, all the way up to IoT cloud connectivity. So really looking at both of those, and this product addresses all of these issues. So we're going to move over to Rufus to talk us through a few different real-world applications that he's come across that address the OT-IT.
Thanks, Colin, and thanks everyone for joining. So I'm going to go over 3 real-life applications. And going back to the OT-IT divide, a few years ago, it was hardly a time where you could get OT and IT personnel in the same room at the same table at the same time. To say they didn't get along with one another is an understatement, right? So what we're seeing in the last couple of years as the IoT, as we're going to, as Colin mentioned, connected everything from connected some things, we're seeing that it's not an option anymore to be in these separate areas. They have to work together. And the more they work together in the planning phase that Colin also mentioned, the more successful that the project can be. So I'm going to get into some examples. The first one is a food and beverage provider in the packaging space. The OEM came to us with the need to connect many different elements of equipment that were designed over practically a 20-year time frame. And so their idea was that they wanted to provide an IoT solution to their end customer as a service. And they wanted to be able to connect upwards of 7 different brand PLCs to the same cloud service interface. And so with 7 different PLCs, in this case, there was several different ones that talk completely different industrial protocols. So in one idea they actually used different small boxes that did one-to-one protocol conversions, and then they pushed that data to a centralized Windows PC that would then get the data through a security router to their cloud services. Very complicated solution in the fact that just setting up and deploying Windows devices with the updates and the patches and all that at the OT layer can be a challenge. And so they were looking to be able to reduce the amount of components to go to one unit and to be able to have one common connection element to the cloud side. So they didn't want to have to redesign or change the software, change the data format every time they built out one of these systems. So what we were able to do was to use a Redline Crimson Gateway. It supports 300 plus protocols inside the box. We're able to talk to those 7, no problem. Then we're able to talk to those 7 units independently, grab their data, and then push it up to the cloud. Some of the advantages with the Redline solution was there's no custom software. There's no licensing. There's no patches and updates that we see like on a practically weekly basis like we do on IPCs. And the gateway was able to run both MQTT and OPCUA. So one of the things that we're seeing in the field is MQTT is very common to get to cloud servers, but OPCUA is common to customer SCADAs. And so, Colin, if you could go to the next slide, please. I've got a topology. So in this case, the customer had pretty much all the big brand PLCs at their machine layer. They had Omron, they had AB, they had Siemens, they had some other ones. So being able to universally connect to them through the gateway and then at the upper end go to the customer's cloud server. In this case, it was Amazon AWS, which is a large provider, was easy to make that connection. And then as well, the customer's plant network was OPC. So it was perfect fit for the gateway. Now, what we're able to do inside the gateway is just drag and drop the tags, move the data, and it automatically processes everything and passes it up. There's no custom VB scripts running to try and process Modbus. There's no custom ProSoft wedges trying to run Allen Bradley drivers. There's no custom interfaces to the Siemens side in the TIA portal. So we're able to do all that inside the gateway, and it made a really clean solution, especially to the top end. In this case, the customer decided that the gateway, since it was so heavy with protocols, with connections, with PLCs, the OT personnel would own the gateway, and from there would be a handshake over to the IT people. Now, from the beginning, there's always issues working with Ethernet connectivity, getting information through servers. So you have to be pretty knowledgeable. The OT people have to know how network ports work, how routing works through managed switches. For instance, to get OPCUA out, there is a specific port. To get MQTT out, there's a specific port. If you don't have a connection, it doesn't work. So those are some of the challenges that we see between IT and OT is they have to work together to make sure that, as Colin mentioned before, it's all about communication and connectivity these days. So the key takeaway here was that they are able to put in a single gateway to keep the programming to the top side the same, and they can change out the bottom side as necessary in more of a modular basis. Okay, Colin, next example, please. We work a lot with the power monitoring industry, and there's some control to the power industry as well. We're seeing a lot more solar systems, diesel backup systems, redundant systems. And some of the customers we have come to us. There's some interesting safety elements that Colin mentioned earlier that we see in power monitoring. This particular customer came to us and they had serial devices and Ethernet devices, and they also had some discrete I/O, and they wanted to be able to get rid of the boxes again. We mentioned before in the prior example, a customer had a box for pretty much everything I just mentioned. They had a serial to Ethernet converter. They had a remote connectivity. They had an HMI. They had a router. Then they had I/O to the PLC. So box after box after box equals big control panels, equals more heat, equals more 24-volt power supplies, equals just complexity that we're seeing start to get streamlined with universal centralized devices. So the solution here was, again, to use a gateway device. What we're able to do with the gateway was to bridge the serial and Ethernet connectivity. So we're able to bring in that data to one place. And then the northbound data, as Colin mentioned earlier, is the same from those units. We're also able to bring in virtual HMIs, some Wi-Fi connectivity, some cellular connectivity. And so why would we do that? Colin, if you could go to the next page, the topology, please. So in a power station, we've all seen these substations and power units and things that they all have a fence around them. And even for the people who are going inside that fence, to open that gate, there's procedures. They have to follow certain things. If they're going to go near certain equipment, if they're going to open certain doors, you may have to put on a full suit, full flat arc flash suit, double gloves, mask. There's a lot to go into some of these high voltage areas. So in this particular case, the customer was needing to talk to power meters that were over Modbus serial RTU, and they also needed to talk to some PLCs and some breaker monitoring on the transformer side of the station. In emergency power backup, there's also phase control of generators, which is really critical for bringing in and out the generator system. You can't just turn on and off a generator. It will cause some really bad things to happen. So there's phase monitoring, there's transformers, there's breakers, there's switching. There's a lot of this is in these power stations. Every bit of it is dangerous. So one of the things that the customer really keened on to whenever we released our FlexEdge product was the Wi-Fi connection. So now they're able to just pull up beside that fence I mentioned in the van and sit there with their laptop and connect via wireless. Now, most of these stations nowadays have cellular connectivity. We're seeing a migration from microwave or radio stations over to cellular. And so you could remotely connect even from their SCADA system. But what if something goes wrong? What if you lose a SIM card? What if you lose that? That means you have to go inside. So having a secondary communication backup with the Wi-Fi was a big plus for the customer. Like I said, just pull up beside it, connect through their secured credentials, get into the system. So what does the gateway bring in this solution? It brings serial to Ethernet conversion. It also can talk to the Ethernet devices, and then it pushes all the data up to the customer's cloud or SCADA. In power industry, it's mostly SCADA, but we see a variation in these elements. Okay, let's go to a third one. Third one's another food and beverage application. In this one, it was a fill and cook application. So a product gets cooked in the line, it goes through a filler. I think we've all got that bag of potato chips, and you open up the bag, and at the very bottom, you see your chips, right? And you look on the side, and you feel like it was a bad deal for you to pay what you did for the potato chips, right? It's settling. We all know the story. It says on the side of the bag, it's 3 ounces, whatever the number is. Well, in the food industry, there's actually auditing and traceability for that average. So there's the USDA, NIST, those people can come and say, hey, where's your records for your information going back to this average? And as long as you make that average, there'll be plus and minuses, then everything's okay. But look at it from the manufacturer standpoint. What if you're over? What if on that 3 ounces, you're 3.1, or what if you're 3.05 on every package? Some of these packages run in the hundreds of thousands per shift. So you start to add up that amount of material, and that's real dollars saved, dollars spent in waste. So this customer is very keen on this information, A, for the traceability, and B, for the process control. So in this case, they had filler machines, and at the end of the line, the product went across a check weighing, what they call a belt weigher. Every time the belt weigh goes across, data comes out of the belt weigher, and it's got data of the time it come out and the weight. So pretty simple interface. But what we were trying to do for this customer is they wanted to get that data, they wanted to record it for the traceability, and then they also wanted to do real-time statistic control. So they wanted to calculate their upper control limits, their lower control limits, their mean, and then they wanted to set some alarms based off of what happened. Hey, if I get to 3.2 average, I'm really wasting material. Let's stop and let's tell some people about it. Let's make an adjustment. So in this case, we used another Red Lion gateway. Colin, if you could go to the second one, please. The gateway that we used in this case was used to grab a raw TCP message from the belt weigher. It does some manipulation of the data, calculates all those statistical functions that we talked about, and then it would send that as data stamp, those timestamps and the weight to the SQL database on the IT side. And as well, it would push it to a live line display at the end of the line. So the operators could look up and see where they're at with their upper and lower control limits, see the mean trending up, trending down, all those things, mean things. And then as well, the process engineers wanted to be able to get the data historically. So they could just hit the SQL database, pull all the data, put it into their mini tab, get the information that they wanted. So in this case, they were able to solve a couple challenges. Was being able to have their traceability for the authorities, being able to see what happened over the shifts, over the time periods, different products, different viscosities, different temperatures. There's a lot of elements in the food that you wouldn't notice for those, especially in the filling applications. So the Red Lion Gateway was able to take that information, pull it together, and make it useful for the customer. All right, that's 3 applications.
Thanks, Rufus. So we're winding down here. So make sure if you have any questions, please feel free to submit those, and we'll address those just in a moment. But so in conclusion, the big takeaways here are the market is changing. It's happening as we speak, and there's both internal within organization as well as external market-driven forces that are causing it. We need to, we talk about how challenging IT can be to work with, or on the flip side, how challenging and stubborn automation engineers can be. That time has come and gone, and for successful deployments, for successful resolution of issues, this idea of cooperative teams is a requirement now. So it's no longer OT versus IT, it's OT and IT. Be prepared to get buy-in, and this can't start at the bottom, it's got to start at the top, and it's got to start with a plan. As Rufus has just outlined, customers are facing these challenges today. So my encouragement is to find manufacturers that support that vision, that can address some of those challenges for you. And that should put you in a good place for success moving forward. So thanks for your time today. We can jump into some questions if any have been submitted.
All right, I have some questions here. Regarding the applications, were there 3 separate Red Lion gateways used for the 3 different examples stated, and why were each chosen for their particular use case?
Good question. I think I'll take that one. So Red Lion has 4 different model gateways, depending upon the customer's topology, depending upon what interfaces they need. They range from a more economical unit to units that are just hardened, explosion-proof, high temperature, vibration rating, whether or not we can add I/O onto them. So that's one of the key points to when we're looking at these applications and in the planning phases is, let's look at these IP address subnets. Do we need NAT translation? Do we need extra security? Do we need remote connectivity? And by looking at all those, they were able to pick between those 4 different models, and they're kind of designed to be able to be scalable as well as to kind of meet the market price and market demand of what we have there. In the examples that I showed you, actually, they were 2 different models. 2 of the models were the same, and then the third one, since it just needed SQL and HMI and raw TCP packet reading, then we used one of the kind of middle of the road data converters for that. But if you have any questions about needing an example, we can be happy to help you with that.
Okay, next question. What can you do to implement security when legacy equipment is being used?
So this is an interesting question because we come across this quite a bit. Legacy PLCs or legacy HMIs, for example. How do you prevent attacks? How do you prevent somebody from putting a USB stick into a device that's infected, for example? And there's a variety of different ways to do that. Rufus actually just mentioned one of the really powerful solutions, which is NAT, putting in NAT gateways or NAT bridges throughout the production line, which can help segregate some of the automation equipment, either by cell or by control panel, or there's a variety of different ways to implement that. But that's a very effective way to limit communication to either what you want or to specific areas of a plant floor. Rufus, do you have anything else that you'd add to that?
Yeah, so I think there's 2 layers to look at how do you implement security. There's a physical layer and there's a software layer. So like Colin was mentioning, different equipment, different subnets, different connectivity. And that's one of the foundations of the Purdue model that Colin had shown before, is that, hey, everything's segregated. And so the idea is that, hey, if someone attacks on level 5, they can't hit level 1. But there's, hackers are they're trying more and more ways every day. So there's always a limit to what can be done. And then the next phase, the next level. So then on the physical layer, it's kind of getting into software control. Managed switches. Managed switches can really help with controlling what's on the network. So maybe we need to stop the attack at the device, and we need to stop it from going further up the network. So with managed switches, we can control what MAC ID comes onto the unit. We can give a notification that something's on the network. That's one of the big questions we get on the security side, is we want, and not only do we want to be able to prevent it as best we can, we want to know if something is an abnormality. Did a technician plug in a laptop they weren't supposed to in a certain port? And that's all can be done with managed switches. Then there's all the security and certs and security support at the software level, user authentication, don't store passwords. So those are all things that can help. I think going back to the original question is legacy equipment. So, there's PLCs running in our OT layer that are 20+ years old every day. They don't have network connectivity. They don't have all these layers. So in some cases, we're adding some of our gateway functionality to the front of those systems just to give it that front line. And why are customers doing that? Going into a machine and completely replacing the PLC to the newest, latest, and greatest can be very expensive. A lot of cases, the end users don't have the source code, so they can't even do it. That means they're going to redesign the whole machine themselves. And so it's kind of a mixed bag of how to control it. But again, it goes back to the plan. This is where the IT people are typically a little better of like what they want to see. And then how do you implement that policy all the way down to the physical layer?
Okay, along the lines of security, does the TLS security support come standard on the FlexEdge, or is that an add-on?
It's standard. We also have cert support as well.
Mm-hmm.
Okay. Are you seeing faster adoption of OT IT convergence in any particular industries?
So what I've seen, I come a little bit more from the industrial cellular side, and those products have been used extensively for the last decade in oil and gas and water, wastewater sorts of applications. So just think remote, geographically dispersed assets. And so there has always been this, I say always, for the last decade, as cellular's been implemented in industrial applications, there has been this fine line between OT and IT as a necessity to transport data. And we've absolutely seen, the OT IT challenge, since that period. I would say that they are early adopters, but they are going through the exact same transformations that I'm seeing in factory automation, packaging, automotive industries right now. Yeah.
All right. In the third example, you discuss, I'm paraphrasing this, the belt weight module and getting the fill level KPI. Whose responsibility is it to define the right data points? And is that the gateway or some other device?
So in this case, it was the gateway. The reason was that a lot of these weighing system OEMs, they're really not giving a lot of data out. It's just a data stream that you can read. So in this case, the gateway was grabbing that. It was then jumping it into the plant network. But the really powerful thing that we were doing inside the gateway is we're actually taking apart the string of the TCP connection that comes in. So it would be a header information. It would be some what article name is being run, like potato chips 1 or whatever. Then the string would also have some separators, and then target weight, actual weight, the units. It would have grams or ounce or whatever it would be. So if you just send that string to something, you would have to parse it through. And that's actually one of the things that the gateway can do, is that we were able to pull apart the pieces of it, and then we were able to attach that to an actual physical tag. So the timestamp and the physical weight are two independent tags. It's not some weird long 30-character ASCII string that we see coming out of a lot of these devices. So the gateway took care of all that, and then it synced it to the SQL and then pushed it to the visualization as well.
Great. Okay, and one other question on the data privacy example. Paraphrasing again, there was some thought that data was allowed to leave the EU. Not sure in the example why the customer had to store the data in Germany on the cloud. Colin, if you have any more insight on that.
So it was actually an infrastructure project that was a state project, and so they required the data to be both accessible and stored only within country because it was a government-sponsored infrastructure project.
And we see that in the U.S. Military, some requirements, some of the large corporations are very keen on protecting their IP, and they want to know and where that data is sitting at, because in some cases the process data or things of that is their, their market advantage.
I see a lot of that in the oil and gas industry as well. So,
Great.
Yeah.
Thank you, gentlemen. That was the last question, and thank you to everybody who submitted questions as well. It's appreciated.
All right. Well, that concludes the presentation. Thank you so much for your time.
All right. Thank you, gentlemen. On behalf of CSIA, I'd also like to thank all those attending. A recording of this webinar will be available for viewing within 30 days of this event. Please be sure to check out our online events calendar for a webinar that you may like to view in the future, and our webinar archive page for a webinar that you may have missed. And with that, that concludes our webinar for today. Thank you, everybody.